Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 9-3 on rotations. This is all the vocabulary and important information we're going to be covering today, so make sure you put this in your notes. Alright, to begin with, a rotation is the transformation of an object about a center point. So there's the center of rotation, and then the object will move in a clockwise or a counterclockwise direction around that center of rotation to a new position. So as you can see here in the figure, the center of rotation here is in yellow, and then the angle of rotation, the amount that it moves in this case, is 40 degrees, and this one goes in a counterclockwise direction. There are both directions. It could have moved clockwise like this one does here, or counterclockwise like the bottom one. Unless it's otherwise stated, always assume it's a counterclockwise rotation. So in your mind as you're going through all of your work today, remember that it's counterclockwise unless it specifically tells you otherwise. A regular polygon, just as a review in case you've forgotten, is both equilateral, meaning all the sides are the same, and it's equiangular, meaning all the angles are the same as well. So in this pentagon, this regular pentagon, all 5 sides are the same length and all 5 angles are the same degree. And each regular polygon has a center as well, right in the middle of it, that is equidistant from all of the vertices. So as you can see in this polygon here, it actually ends up kind of breaking it into 5 separate triangles. Triangle 1, 2, 3, 4, and 5. So it breaks it into 5 separate triangles that are all congruent as well, and into 5 separate pieces. If you remember that a circle has 360 degrees of rotation, each piece would be 360 total divided by 5. So each piece of this is approximately 72 degrees. So if you were to rotate it, you might find some figures have rotational symmetry while others don't. This star, for example, does have rotational symmetry. As you flip it over, it looks exactly the same as it did before, whereas the butterfly does not. The butterfly starts here looking straight, and then it goes to the side, upside down, the other side. This one does not have rotational symmetry, whereas the star does. So the same thing here, this regular pentagon does have rotational symmetry, and it rotates on an axis of 72 degrees. Each point here is 72 degrees from the next point. So let's go ahead and do some of your homework. All right, this one here has several questions attached to it, and we're going to do a couple of them now. 120 degree rotation of B about point O. So here is point B, and here is point O. So what we want to do is rotate B about point O 120 degrees. And it tells us that each of these segments is 30 degrees. Remember, we want to go counterclockwise, so this way, like this. So the B to the A would be 30, 60, 90, 120. So to rotate B about point O 120 degrees would put you at point H. For our second one here, we want to start with point M, and we're going to rotate point M around point L 720 degrees. So if we were to rotate it about point L 360 degrees, we would end up right back where we started. And 720 degrees is much closer to 360, a full rotation, than it is closer to 0. So when you move about, what you'll see is that 270 degrees out of 360 degrees is actually 3/4 of a full rotation. And so what happens, it's a little hard to show you here as you go around, but you come back, but what happens is you come back up all the way here to point K, which is only 90 degrees off of your 360. So in this case, it's actually easier to think about it as what's missing, which is the 90 degrees from here to here. And for our last one here, we have a 300-degree rotation of segment IB about point O. So you can pick either the I or the B, and it doesn't matter which one you choose. I'm going to go ahead and start with the I. Remember, a 300-degree rotation is only 60 degrees shy of going all the way around. But you can go ahead and count it from forward as well. So 30, 60, 90, 120, 150, 180, 210, 240, 270, and then this point right here would be 300 degrees. And so that's where I would move to, and it would become kind of I prime, and the B would follow along behind it right here, and this would be B prime. And so your answer here would be segment BC. All right, our next question here wants us to find the angle of rotation about point C that maps point Q to point X for our first part and point X to point Q for our second part. So to go from point Q here to point X, we're going to move just this far of the circle. It is important to figure out how many points there are here on this rug. And so I've kind of made like spokes on this circle here, and there are 10 of them. So each of these segments is a 1/10 of 360 degrees, which is 36 degrees. So from here to here is 36 degrees, and from here to here, from each of these is 36 degrees. So to go from this point here, 36 degrees times 2 times 3, which would be a total of 108 degrees from Q to X. To go from X to Q, however, we'd have to move 36 times 1, 2, 3, 4, 5, 6, 7 spots to get back over here. And 36 times 7 is 252 degrees to map from X to Q. You could also say that from this point here in yellow to this point here in yellow, if we know that this is 108, you can take 360, subtract the 108 that we know, and you'll get the resultant, which is red, and it's 252 degrees. Good luck, everybody. I hope you guys all do great.